All right. Welcome to day three. I know this video was supposed to be posted last week, but here we are. So in today's training, we'll be looking at inputs, outputs, and basic operations, right? So what we mean by inputs is we'll be prompting user to um, input a particular a variable while we use it for something. And then we'll print out an output with respect to what the user has given to us, right? And then we perform some basic operations that has to do with comparison and logic. So as at for the day two, we looked at data data types, data variables, and we looked at data types, variables, and basic operations, right? So the basic operations we looked at last week was just arithmetic operations. So in the arithmetic operations, the normal mathematical operations were what we looked at. But today, what I'm basically going to show you is how to get user inputs and also to format your strings, right? So if we'll see how to format strings. I told you the other day that I in the previous video that I'm going to deal with how formatting of string explicitly, and then we'll now look at the basic operators. So, the part two of the basic operators. This one has to do with logic and comparison. So we'll look at this as well. So, and then we now try to see how if we can create a simple calculator program with respect to the user input of length, the string formatting, and the basic operation. Calculator has to do with some plus minus and all that. But this is going to go beyond that to perform some comparison and all that, right? So let's move forward. Python uses the inputs open bracket function. So this is the function that Python uses. This function, input open bracket function to get users function, right? So what this implies is that when you want to get user function, you use inputs is what you use for the user function, right? So this is the function we use to get users function. So it's just like the basic the normal English, which you say input does, right? So when you demand a user to input a variable, this is what you are expected to use. This is the function you're expected to use. So the input function is always returned as a string, right? So the inputs always comes as a string. So if there is need for us to get a different data type, we must do what? We must convert it using the data initials, right? So because we said input comes with return string, so if I say input uh inputs, then I now said how old are you, right? So if I click on this guy and I say input, how old are you? How old are you? This is it now. And I try to run this code. It will be demanding that the user should do what? Input how old he or she is. And then you're putting like, let's say 56, right? So see the output here. The output is showing as a string. Remember I told you how to differentiate between a string and an integer. So this is a string because it's encoded, encoded, enclosed in a quotation mark, right? So that is what we are saying here, that it usually returns a string. But if I come here and I say int, int open, sorry about that, int open bracket, and then what's going on? Sorry. Okay. So it's telling me how old are you? I said 56. If you see now, it has changed to how do you call it on integers because it does not have that enclosed quotation mark, right? So let's move forward very quickly. Getting user inputs. So I now said this is how to code when you're trying to get user input, right? You can get as much input as you can. This is used for user interface building, right? Where you say email, password, and all those guys. So this is the scratch of building that kind of interface when you're working with Python. So we say I now said name is equal to input what is your name. So this is a question that is going to pop up. Remember, your input function will prompt the user to input to supply you an answer, right? And then inside of the function, you have to describe what the user needs to do, right? So let's see something else here. Imagine I just say input and I open my bracket. This guy is going to appear like this, right? But the user wouldn't know what to do. So as I've known already, I can easily do this and it will still print out 56. But when you describe what you want the user to do, like this, what is your name? The user will quickly know that, oh, this guy is actually looking for what my name, right? And then age, the same thing happens to age, right? But because we said that input function only returns string or string data type, we have to do what? Convert that string data type to what? To integer, right? So when you convert that string data type to integer, what is going to appear, because it is never possible in history that somebody will have an age that is a string, right? No, it's not possible. So that is why we have to convert it to what? An integer. And it's not possible for somebody to have a float as an age. So if you tell me that you're 21.5 years, no, it's not possible. It's either you're 21 or you're 22. So there's no in between the gap, right? And that's why I'm using this guy. Then for height, so we could have somebody that is 6.5 feet tall and all that. So that's why we are using a float. So I would say enter your height in meters, right? So you can be somebody can be 2.5 meters. Is it possible? Right, yeah. So the input here will always return what? A string. But then we will have or we would like to convert it to what? To a float because it has floating part, which is decimal. Even if it is 6, we know that okay, it can also be what? 6 point something, right? So if I should run this guy, let's run this. Sorry. So, okay. Yeah. So I now is asking, what is your name? I said, Ben is my name. How old are you? 67. Then what is your height? 6.1 meter, right? So this is it now. This printout function is just an empty space, right? Then we have print, open bracket, hello, comma, name. The name is that you're going to enter, right? This name here. Then an exclamation sign. This is just a normal way of expressing something in English language. So the exclamation sign, you are, the age, years old, and height, meters tall, right? So this is it. This is the output here. Hello, Eben. you are 67 years old and 6.1 meters tall, right? So this is the output that we are getting from uh, Python, and this is what it is showing us here. So let's quickly handle string formatting. String formatting. So string formatting allows you to include variables in string, right? So this is it now. Here, from this guy, hello, down to this guy, full stop, everything that is inside of this place ought to be what? A string, because there's an enclosed quotation mark. There's a double quotation mark here. But then we were privileged, or we were by chance able to include variable names, right? We have name, we have age, and we have what? Height. So what allows us to include these guys here is this thing called string formatting. And that is why this F guy is here. So the F guy will tell Python, look, I have some variables that I've declared already, and I want to include them here. So please kindly help me, or allow me to go ahead with the inclusion, right? So that's one works for it. So I have my age here, sorry, name, age, and height being included in the string right up here, right? So that is what string formatting does. So there are three methods to string formatting. So there are three methods, and basically, as the world evolves, or as things continue to go to evolve, we realize that there are new ways of doing things, right? So the first style is a very old style. So I used to call it an archaic style, where you make use of what's your percentage sign for formatting. So this percentage sign, what it does is that when you have your print function, right? I have it here to be print, and I said, remember when, I don't know whether we still remember when we used to do print and all that. So I will say print. Whenever you say print hello or print hi, even, right? So this is what's gonna come out. So let's make it more cool. Hi, even, right? This is it. So whatever you put inside of this function print is what is gonna come out, right? So that's purely what I am looking out for. So anything that enters into this print function is what you should be expecting. All right. And then, because that is what we are expecting, I have a print function here that says hello, comma, right? Look at this now. I'm having a percentage sign with S attached to it, and what? A what? An exclamation sign. So what this implies is that this place where I'm having an S and an exclamation sign is telling you that I have a variable I need to include here. But I would attach that variable when I'm done with writing the strings, because the strings ends here, right? And then I have another one here, percentage D, right? Percentage D. And I'm saying that, look, I also have another variable to include as well. And at the end of the string, I will say this percentage should allow us to include what? Age, sorry, name and age. Name, comma, age. So that if I should run this, what's going on? So if I should run this guy now, I'll be having what? Hello, Eben. You are what? 67 years old, right? So this is one of the methods, but I see this method to be very, very old and archaic, and at the same time, it looks it's kind of look difficult for one to understand and comprehend wholesomely. But if but the other methods, like let's say the second method, which is the string dot format method. This is it now. String dot format method. So under the string dot format method, I have it that print, right? Hello. Then I'll have to include what? An open coily bracket and close it. So there's an introduction of what open coily bracket that is closed as well. So this one is telling you that there should be something here. We are expecting something here. And at the same place, we are also expecting something here, right? And then at the end of everything, without giving a space, I will say dot format name and age. So your position of placing the variables is very, very important. So this name goes to this first coily bracket here. Then the second variable, which is age, goes to this guy here. So that is basically what it is. So if I should run this guy, oh, this guy is misbehaving. So if I should run this guy, I'll be having what? Hello, Eben. You are what? 67 years old, right? So that is that for string formatting. I've said we have the percentage format, which is an old style, and the second one we just did now is what the string dot format method. So the last one, which is the contemporary one, the one we're using in Python, it started from Python 3.6, and I don't think it has been updated yet. So the is the F strings, the F strings. So this is the most recent one that Python is still using even in their new updates. And it says that print, open brackets, you introduce the format, which is F. So F, alphabet F or letter F is what is used to initiate, or yeah, initiate is the word, to initiate your variables. So this is it. You have a coily bracket open and closed with the variable inside of it like this, right? And then the same thing is applicable to this one. So here, you already know that, okay, what is coming in here is what? Name. And what is coming in here is what? Age. By so doing, anybody that is reading this code will know that whenever I say hello, I should be expecting somebody's name here. And then how old you are, what? I should expect the person's age here and the remaining write-ups, right? So let's try to run this guy. Oops, sorry. I think my keyboard is misbehaving this morning. Oops. I have to manage this. I'll fix it. All right. So he's saying, hello, Eben. You are what? 67 years old, right? So I have an example code where I experimented all of those styles and it could be very, very helpful. So I have name equals to age, sorry, name equals to Eben, right? And I have age 29. I have pi being what? 3.14159. And then the old formatting method is what? This, which is saying what? The old formatting method is uh the use of percentage, right? So under the use of percentage, we'll be seeing that I have hello, this guy, right? You are this years old, full stop. And then pi is approximately this. So here where I have dot 2f is telling you that I need this guy to be displayed in two significant figure. No, in two decimal places, right? So that is basically what I want to do. And after everything, I have to include this and at the same time say that the first variable that I expect to appear here is what? Name. The second one is what? Age, and while the last one is pi. So for the string format, we have hello, this guy, open and close a curly bracket. Your this guy age should come here and then your pi here. So look at how to format uh uh to the nearest decimal places. So you have an open a you have a column dot 2f. So what 2 means is that it's going to be in two um decimal place. So if you make it 3, it will also appear in 3 decimal places. Dot format, name, age, and pi, right? And then using, if we were to use f string, the same thing is just applicable. Just introduce your f in front, and then you include your variable names at the appropriate places where you want them to be. Then this is how to format. So while you include your pi, then you now say column dot 2f to make it what? Two decimal place. Two decimal places. So let's quickly look at this one before we go to the practice exercise for today, right? So basic operators. We have comparison operators. Last week, I think we talked on the arithmetic operators, that one that has to do with plus, minus, and all that. So, but today we're going to be looking at comparison operators. What this comparison operators does is that we use comparison operator when we are handling conditional flow, condition and control flow, right? So because we need to study I think condition and control flow will be the next topic. That's why I brought this one here, so that we'll understand how this comparison looks like. So comparison, when the word compare has to do with trying to place two things side by side and see which is better, or which is true and which is not true, right? So we use to compare, we use the following during comparison. The first one is double equal to. So when you're using this double equal to sign or double equality sign, this guy is comparing what is on the left hand side to what is on the right hand side. So mind you, in Python, when you are using a single, oh, coming. Okay, when you're using a single equality sign, the single equality sign is for assigning a value to a variable. Let's say, for instance, I have this guy here, name being equal to Eben, right? And name being equal to Eben, this will implies that wherever I see name, I should be expecting a value Eben, right? So this is purely what the single equality sign does. But when I come to double equality sign, I'm trying to compare, is this guy here equal to this, right? So if I should include another equality sign here and try to run this guy, I'm sorry about that. My keyboard has been is been misbehaving this morning. All right, so I tried to run this guy. It will tell me what? True. Do you know why this thing is telling us true? It's because we've assigned Eben, which is a value to this name already, right? So if I should clear this n and try to run it again, we should be expecting what? Name AMN is not defined, right? So, but most of the times, I try to see how I can use values. So let's say 78 is 89 equal to 78. What you should be expecting is what? False, because this guy isn't the same as this one, right? But for variable names, once I declare a value that has the same variable as another value, once I declare a variable rather that has the same value as another variable, so let's say for instance I have, sorry, I really have to work on this today for the next video, please. Okay, let's say I have okay, I'm coming. I will resolve this quickly. I think if I should restart this, it will work, but I can't do that now. We've gone long way. Okay, but let's just try to manage this, please. Okay, so under here, I was saying that if, oops, wow, this has become unbearable. This is becoming unbearable. Okay, so now, let me put this guy on markdown. I hope it works that way. And okay, let it still be on raw. Oh, yeah, so that you see it very closely. Okay, so for this first guy, for this equal to, that's what I've explained, right? And I'm saying that it tries to compare. It tries to compare between two two variable or uh two values, right? Man. Yeah. And then the second one, not equal to. So if the first one is equal to, I now said I want to try to compare when things are not equal. So the operator to use is the exclamation sign behind an equality sign, right? Exclamation sign behind an equality sign. And this one, when you try running this, okay, don't worry, we'll have a lot of examples behind here. So let me just be explaining all of this guy, uh, all of those guys before we go to the example, right? So the third one is greater than, just the normal greater than your right hand elbow, and then the less than sign. So greater than what is on the left should be greater than what is on the right for this arguments to be true. And then for this guy, what is on the left should be less than what should be on the right for this guy to be true, right? And then for the fifth one, we have greater than or equal to, greater than or equal to. So when we look at greater than or equal to, is actually a range of values, right? So we want to say that the value in the value, what is on the left hand side is greater than or equal to what is on the right hand side. So this, what this implies is that if what is on the left hand side is actually greater than what is on the right hand side, it will be true, right? This argument will be true. And this at the same time, if what is on the left-hand side is also equal to what is on the right-hand side, the argument will still remain true. So basically, for this argument to continually remain true, everything on the left-hand side has to be at least equal to the one on the right-hand side or greater than the one on the right-hand side, right? And the reverse is the case for less than or equal to. So we just go the reverse direction. What is on the left-hand side has to be less than what is on the right-hand side. And or what is on the left-hand side has to be equal to what is on the right-hand side. So that is that for the explanation. So I have an example here. I declared x to be equal to 10, and I declared what y to be equal to 15, right? And I said for the first line, print is x equal to y, right? And I'm saying x, this is the condition I'm giving to it. X is equal to y, right? I'm using the comparison here. X equal y. So if you run this, you get the answer. The same thing is applicable for the second one, right? Not equal to. So just be looking at these operators I'm using here: equal, greater than, less than, equal to, or greater than, and this one. So let's run this guy and see what should be our output. So the first one is saying that I have a question. Is 10 equal to 15? And the answer is what? False. Because when I compare 10, which is the value for x, or compare it with the equality sign to y, you will notice that it is not true, right? So 10 can never be what? Equal to 15, right? And the same thing is applicable for the second one. I'm asking, is 10 not equal to, is 10 not equal to y? That's it. Is x not equal to y? So I will now make use of the operator exclamation sign equal to, right? So that one will now tell us if the value on the left, which is x, is equal to y. And the third one is x greater than y, right? So x being greater than y. Then another one is x less than y. So this is it, x being less than y. And this one is x greater than or equal to y. So let's run this so that we explain for that. So the first one says what? Is 10 equal to 15? The answer is what? False. Is 10 not equals to 15? The answer is true because 10 is not equal to 15. And then is 10 less than 15? The answer is what? True, because 10 is less than 15. Then is 10 greater than or equal to 15? So the answer is false, because when you try to check if 10 is greater than 15, it's false. And if you check for the second condition, if it is equal to 15, it's also what? False. So the last one is 10 less than or equal to 15? The answer is true, because it satisfies this condition, less than, right? So that's for that. The next is the logic operator. The logic operator, right? So the logic operator, just like we did when we were back then in high school and in uni, the logic gates, right? Where we have the and, the or, and the nan, right? So here in Python, we have the and the or and the not, right? So and returns true if both conditions are true, right? So we liken this AND to be, yeah, the same AND gate, like AND gate, right? Then OR returns true if at least one condition is satisfied or is true, right? So when one condition is true, or will return true, so long as one of the conditions that is being placed there is satisfied, right? And then not negates the condition. So under not, we are trying to see it goes against the condition that is being placed there. So if I see 10 is not greater than 20, so it will be true, right? Because it is not, it negates the condition. The 10 can never be what's greater than 50. So I have here, so this logic operators, it allows us to combine more than one condition, more than one comparative or comparison operators, right? So I have here for the logic and I have print. Okay, I declared this guys already. A to be equal to 10, B equal to 20, C equal to what? 15. And then I have on my logic gate that print is A less than B and is B greater than what? C, right? So this makes much sense because I'm trying to compare these two guys, A being less than B. So mind you, what AND gate does for us is that the two conditions you're trying to compare, they must be true. The both conditions has to be true for it to output true for us, right? So I'm saying is A less than B. So let's go back to where we have our A. Where do we have A? So this is A being 10, right? And then this is A that's 10 and B is what? 20. So actually A is less than B. That one has been satisfied. And then is B greater than C? B is 20 and C is what? 15. So we can say that this also is true. So the two conditions have been satisfied. So what we are expecting here, remember when you're done, this one is just for the normal formatting. This is where your condition logic and appears, where you say A less than B and B less than C. So this is where your logic and comes in, right? So remind you, you make use of the keyword AND and in small letters. And then for logic OR, you just replace it with OR, right? The same condition. And then for not, we are saying that we are looking at print is not A greater than B, right? Does this really make sense? So we are saying not A being less than B, right? So if is not 10 greater than 20, so it's a kind of is like a question I was trying here. Is not 10 greater than 20? So it will say true. Why does it say true? But in the real sense, 10 can never be greater than 20, right? So this not negates the condition you're giving it. So if you're saying 10 to be greater than 20, okay, let's see something. Let's try this guy with uh less than. Yeah, let's try false. False, right? Here should be less than. Okay. It's saying false. 10 It's saying false. So what NOT gate does is that it goes contrary to the correct thing. That's just what I can explain right now. Because if you look at this guy, I have 10 to be a value for A, and I have 20 to be a value for B. So ordinarily, we know that sorry about that. All right, we know that A should be less than B, right? Because we have A to be 10 and B to be 20. So it's normal that A is less than B. But when you introduce not, it will tell you, no, guy, I don't think A is less than B. This thing should be A is greater than B, right? So not just negates what we know and gives us the wrong or the opposite of the correct answer. All right, so I have a simple calculator program. So this code, I'll leave it to you to practice it. And if you have any challenge, you let me know. But just a brief explanation. Let's go. It's a simple calculator program. And then remember, I told us this guy is always a comment. So the first thing is welcome to the simple calculator program. That's what should appear first, right? I think I have to optimize this guy. Let me see if I can do something on this. All right. Say welcome. So there will not be a space. I have to get some user information or user input. So the first one is num1 equals to float. Enter a number. Enter the number first or the first number. Then the operator sign. So these are the signs I declared. These are the signs I'm telling. Deposit plus, minus, multiplication, division, and this other guy here. This is our guy, modulus, right? Then enter the second number. So for operation, you have the first one for plus. If operator is plus, do what? Num1 plus 2. Then if operator is minus, num1 minus 2. Just a simple one. So if num2 is not equal to 0, right? Because if we have num2 being equal to 0 for the division, we'll realize that it will be giving us infinite error, right? So and then I now raise a condition. If it is not, so you do the division and send out the results. But if it is, raise an alarm that's error division by 0, right? And then else if operator being equal to modulus, you do this guy. Then else invalid operator, right? That means you've not entered the right operator. So you now print the result is result in any of this guy. So let's try to run this. Enter a first number. I choose 7 to be my first number. I choose minus to be my operator. And now choose the second number to be 3. And my answer should be 4.0. Right? So with this, I've been able to show you through um use input, user input, and then string formatting, and we've looked at basic operators and as well tried to see how we were able to build our simple calculator, simple arithmetic calculator, right? So I'm gonna try to see if I can drop another videos today for the second week that has to do with I think that's one should be for um okay, control flows, right? And then we now look at functions. So after control flows, we look at functions. So that will be all for today. If there's any challenge, let me know and then we'll resolve and put them together. Thank you very much.